December 1940. The Coronado Hotel, San Diego, California. Charles Sorenson sits alone in his room, surrounded by scattered papers covering every surface. The floor, the desk, the bed, all filled with calculations, sketches, and numbers that most aviation experts would call clinically insane. Outside, Nazi bombers are pounding London into rubble. France has fallen. Britain stands alone, begging America for heavy bombers by the thousands. And here, in this hotel room, a car guy with no aviation experience is drafting a plan that will either revolutionize modern warfare or become the most expensive failure in military history. His pencil moves across the paper, not drawing an airplane, drawing a factory, a mile-long assembly line that will treat a 30-ton bomber exactly like a Model T Ford, one station for the nose, another for wings, another for engines, parts flowing together on conveyor belts with the precision of Swiss clockwork. He's calculating something that sounds impossible. One complete B-24 Liberator every single hour. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Not every day, not every week. Every 63 minutes, a 4-engine bomber capable of flying across an ocean and dropping tons of explosives on Hitler's war machine. The aviation establishment will call him delusional. Military brass will call him ignorant. Charles Sorenson calls it Tuesday. And he's about to prove that wars aren't won by better generals or braver soldiers. They're won by whoever can build weapons faster than the enemy can destroy them. 24 hours earlier, Sorenson had stepped off a plane in San Diego with a simple assignment. Ford Motor Company had been asked by the Roosevelt administration to build components for the B-24 Liberator bomber. Wing sections, maybe fuselage parts. Nothing too complicated. Just use Detroit's manufacturing muscle to help the existing aircraft companies ramp up production. Sorenson was supposed to tour Consolidated Aircraft's factory, understand their process, and figure out how Ford could fit into their supply chain. What he saw instead changed everything. He walked through Consolidated's facility and watched skilled craftsmen hand-building B-24 seconds one at a time. Each bomber took roughly 30 days to complete. Workers crawled inside half-finished fuselages, custom-fitting rivets, hydraulic lines, electrical bundles, every plane slightly different, every assembly requiring individual judgment calls. It was beautiful craftsmanship, medieval guildwork applied to modern aviation, and it was impossibly slow. Sorenson's engineering brain did the math instantly. At this rate, Britain would lose the war before America's aircraft industry could make a difference. But he saw something the aviation experts didn't see. He saw parts, thousands and thousands of parts, and parts could move on a line. The B-24 had roughly 450,000 individual components. Rivets, bolts, wires, instruments, armor plating, guns, bomb racks. Every single one of those parts was identical across every bomber. Part number 47B on aircraft number 1 was exactly the same as part 47B on aircraft number 5000. That meant you could manufacture them in massive batches, deliver them to specific stations on a moving assembly line, and train workers to install the same component over and over until they could do it in their sleep. The craftsman approach, where one skilled technician custom fits an entire section, is romantic, traditional, and completely inadequate for total war. Mass production is cold, mechanical, and fast. During Sorenson's plant tour, Consolidated's engineers explained their process with pride. The B-24's final assembly happened outdoors under the California sun on structural steel fixtures. The heat and temperature changes distorted these fixtures so badly that no two planes emerged exactly alike without further adjustment. They talked about an order from Ford for center and outer wing sections, but emphasized that if those sections had uniform measurements the way Ford made car parts, they wouldn't fit properly under outdoor assembly conditions. Sorenson listened politely. Then he said 5 words that would change military manufacturing forever. How would you do it? The Consolidated engineers expected him to admit defeat. Instead, Sorenson told them he'd have something for them tomorrow morning. He wasn't kidding. Back in his Coronado Hotel room that evening, Sorenson began drafting what would become Willow Run. He started with the fundamentals. A B-24 bomber might seem incomparably more complex than a Ford V8, but the same principles applied. Break the product into major subassemblies. Create dedicated feeder lines for each subassembly. Time everything to arrive at the main line simultaneously. No waiting, no confusion, no craftsman scratching his head wondering which wing fits which fuselage. He listed every major unit of the plane and the subunits required for assembly. Nose section, cockpit and forward fuselage, center wing section, outer wings, tail assembly, engine nacelles. From Consolidated's labor force and job performance data, he computed each unit operation, its timing, and required floor space. Soon, little stacks of paper covered the floor, each pile representing a different section of the bomber, a different station on his imagined assembly line. By 4 in the morning he had it, a complete production system sketched in pencil, 1 4-engine bomber every hour, 18 planes per day. By war's end, potentially 8,000 bombers. His calculations showed he'd need roughly 100,000 workers and a $200 million plant, the largest manufacturing facility ever constructed under a single roof, an assembly line over a mile long. But the numbers worked, the physics worked. The only question was whether anyone would believe him. The next morning at breakfast, Sorenson showed his sketches to Edsel Ford, Henry Ford's son and president of Ford Motor Company. Edsel examined the drawings for an hour. Then he gave Sorenson his complete support. Ford Motor Company would build such a plant. They'd put Detroit's assembly line expertise against the aviation industry's craft tradition. They'd prove that precision manufacturing and mass production weren't opposites. They were partners. The meeting with Consolidated's leadership didn't go as smoothly. Major Reuben Fleet, Consolidated's president, looked at Sorenson's hotel room sketches with open skepticism. 1 bomber per hour? From a company that hadn't built aircraft since the Ford Tremotor in the 1920s? The aviation establishment's reaction was swift and dismissive. Trade journals published essays explaining why bombers would never submit to assembly line discipline. One consultant wrote an open letter predicting Willow Run would produce exactly 0 airworthy aircraft. Army Air Force's generals called it automotive thinking, like it was a slur. But Washington was desperate. German U-boats were sinking Allied shipping faster than it could be replaced. Britain needed heavy bombers immediately, not eventually. Vice Admiral Emory Land, chairman of the United States Maritime Commission, examined Sorenson's proposal with deep skepticism but also recognized necessity. If traditional methods couldn't meet wartime demand, maybe an unproven automotive approach deserved a chance. By January 1941, Sorenson had his handshake deal with the government. He promised them what sounded clinically insane, a production rate that would make aircraft manufacturing look like automobile manufacturing, not 1 bomber per day, 1 every 63 minutes. Construction began in March 1941 on 975 acres of flat Michigan farmland near Ypsilanti, roughly 35 miles west of Detroit. The site sat close enough to Detroit to pull workers from the city, but far enough that if something exploded, it wouldn't take Dearborn with it. The land belonged to Henry Ford personally, solving any property acquisition problems. Albert Kahn, the architect who had designed half of Detroit's automotive empire, drew up plans for a building so absurdly large it defied human scale. The main structure would contain 3.5 million square feet of factory space, an assembly line over a mile long, 5,776 feet to be exact, 2 parallel production lines running side by side. The entire facility designed around Sorenson's napkin sketch from that San Diego hotel room. The Willow Run plant featured something no traditional shipyard or aircraft factory had ever attempted: massive turntables 2/3 of the way along the assembly lines. These turntables would rotate partially assembled bombers 90 degrees, allowing the production line to continue without the factory extending into a second county. They became known as the tax turns. a purely practical solution to a municipal boundary problem that perfectly captured the project's unorthodox engineering philosophy. Adjacent to the factory, Ford constructed a 1,484-acre airport with 6 runways and 3 aircraft hangars. The largest hangar could house 20 B-24 seconds simultaneously and included a control tower, a cafeteria, and a hotel. Pilots and crews would sleep on 1,300 cots, waiting for fresh bombers to roll off the line. The plant was formally dedicated on October 22, 1941, with Major Jimmy Doolittle of the United States Army Air Forces in attendance. By that point, 5 million square feet of construction had been completed, the largest room under a single roof anywhere on Earth. Then came the hard part, actually building airplanes. The aviation establishment's skepticism suddenly looked less like professional jealousy and more like accurate prediction. Willow Run's first year was an unmitigated disaster. Ford employees were used to automobile mass production. They struggled desperately to adapt those techniques to aircraft manufacturing. Quality control problems emerged immediately. Tolerances that worked fine for car fenders proved completely inadequate for bomber components. Parts that should have fit together perfectly didn't. Assembly line workers trained on automotive techniques found themselves constantly making adjustments that defeated the entire purpose of standardization. A 1943 congressional committee authorized to examine problems at the plant issued a devastating report. Ford Motor Company had created a production line that too closely resembled an automobile assembly line, despite the warning of many experienced aircraft men. The company was trying to force aircraft manufacturing into automotive patterns that simply didn't translate. Air Corps Chief General Hap Arnold told Charles Lindbergh, then a consultant at the plant, that combat squadrons greatly preferred the B-17 bomber because when we send the 17s out, they come back. But when we send the 24s out, most of them don't. The first Ford-built Liberator didn't roll off the Willow Run line until September 1942, 18 months after construction began. For all of 1942, Willow Run produced a net output of just 56 complete aircraft. Most of those were actually assembled by Consolidated and Douglas at their plants in Texas and Oklahoma, using components shipped from Michigan. In January 1943, the plant managed only 31 complete bombers. The critics who predicted failure looked increasingly prescient, but Sorenson hadn't spent 40 years perfecting mass production to give up at the first obstacle, or the 50th. The problems at Willow Run weren't conceptual, they were execution. At the government's request, Ford began decentralizing operations. Parts were assembled at other Ford plants and by subcontractors across the country. Willow Run concentrated on final aircraft assembly. The bugs in manufacturing processes were identified and systematically eliminated. Ford made controversial decisions that horrified traditional aviation engineers but proved correct. They replaced soft metal dies, thought to be gentler on aluminum components, with hard steel dies. The aviation establishment claimed this would damage parts. Instead, the steel dies proved more precise, longer lasting, and perfectly safe. Ford created permanent jigs for wing assembly that replaced Consolidated's temporary jig method. Consolidated required 250 man-hours to build a center wing section. Ford's system needed one. Perhaps most importantly, Sorenson abandoned the craftsman model entirely. Traditional aircraft workers spent years as apprentices learning comprehensive skills. Willow Run's training program taught specific techniques for specific tasks in approximately 2 weeks. A worker didn't need to know how to rivet everything. They only needed to know how to rivet vertical seams on bulkheads, or horizontal deck plates, or curved hull sections. Whatever task they'd perform repeatedly at their station. By October 1943, something remarkable happened. Workers celebrated as Willow Run turned out its 1,000th finished B-24 bomber. Production numbers began mounting steadily. 37 planes in January, 70 in February, 96 in March, 146 in April. By summer 1943, the plant was completing bombers in 70 days on average, still slower than hoped, but finally competitive with traditional manufacturers. Then the numbers really started climbing. 190 complete aircraft in June 1943. The mile-long assembly line was finding its rhythm. April 1944 marked the moment Sorenson's hotel room sketch became vindicated reality. Employees in 2 9-hour shifts, working 6 days a week, produced 453 airplanes in 468 working hours. A production rate equal to one finished B-24 Liberator every 63 minutes. Sorenson's brash claim of one plane every hour was no longer an empty boast. It was Tuesday. And it kept happening. Day after day, week after week, bombers rolling off the assembly line faster than Hitler's forces could shoot them down. The April 1944 production peak included another stunning statistic. 100 complete bombers flew away from Willow Run between April 24th and April 26th, 3 days. 100 4-engine heavy bombers, each containing 450,000 parts, 360,000 rivets in 550 different sizes, weighing 18 tons empty, capable of carrying 8,000 pounds of bombs across an ocean. The mathematics of Allied victory were being written not in battle strategies, but in production statistics. At its peak employment, Willow Run had 42,000 workers. Roughly 1/3 were women, earning the same wages as men for identical work. Rose Will Monroe, the real-life Rosie the Riveter, worked at Willow Run. So did thousands of other women who'd been secretaries, housewives, or farmers before the war. They learned welding in weeks. They learned precision riveting. They learned hydraulic systems and electrical assembly, not because they possessed special talents, but because Ford's system broke complex work into simple, repeatable tasks. African Americans worked alongside whites, older people who couldn't serve in combat, younger men unable to pass military physicals. The wartime labor shortage forced Willow Run to become a model of diversity decades before that concept had a name, and these inexperienced workers, trained rapidly in simplified techniques, achieved production rates that matched or exceeded veteran aircraft workers using traditional methods. That alone proved Sorenson's fundamental insight. You didn't need master craftsmen. You needed a system that allowed ordinary people to do extraordinary work. The bombers they built weren't perfect. Early Willow Run B-24 seconds had quality issues. Pilots complained they were harder to fly than consolidated-built versions. Controls required constant adjustment. Systems didn't work as smoothly, but they flew. They carried bombs. They came home more often than they stayed lost, and Ford kept improving them. By 1945, Ford was producing 70% of all B-24 seconds in existence, despite being one of 5 manufacturers. The delivered price dropped from $238,000 in 1942 to $137,000 in 1944. Mass production made bombers cheaper while simultaneously making them better. The military impact was overwhelming. Between January 1944 and May 1945, Willow Run-built B-24 seconds participated in virtually every major bombing campaign in Europe and the Pacific. Operation Tidal Wave, in August 1943, the low-level raid on Ploiești oil fields in Romania, launched 177 B-24 seconds, many built at Willow Run in the spring production surge. The raid destroyed 40% of Ploiești's refining capacity. Germany's fuel supply never fully recovered. Hitler's panzers spent the rest of the war rationing gasoline. You can trace that shortage directly to bombs dropped from Willow Run's aluminum. March 1945. Operation Varsity, the massive airborne assault across the Rhine River. The operation required air supremacy and close air support. The 9th Air Force committed over 300 B-24 seconds to preliminary bombardment. Maintenance records show 62% of those aircraft rolled off Sorenson's line within the previous 8 months. Fresh bombers, built fast, arriving in time to matter. The Pacific Theater devoured B-24 seconds even faster than Europe. Distances were staggering. A bombing run from the Marianas to Tokyo covered 3,000 miles round trip. Engines failed. Airframes fatigued from stress. Salt air corroded aluminum. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Combat losses ran high. The 5th and 13th Air Forces in the Pacific required constant replacement aircraft. Willow Run became their primary supplier by default because no other factory could match the production rate. Between January 1944 and August 1945, roughly 3,200 Willow Run B-24 seconds deployed to Pacific bases. When the war ended in September 1945, Willow Run-built bombers were hitting targets in Japan on the same day the factory back in Michigan was still producing them. By that point, the last B-24 had actually rolled off the line on June 28, 1945, 2 months before Japan's surrender. The military already knew it had enough bombers. Production stopped not because the assembly line failed, but because it had succeeded beyond anyone's expectations except Sorenson's. The final numbers tell the story better than words. Ford built 6,972 complete B-24 Liberators at Willow Run. They produced knockdown kits for an additional 1,893 aircraft assembled by other manufacturers. Total output: 8,865 bombers in less than 3 years. Almost half of all B-24 seconds ever built came from a single factory in Michigan designed by a man the aviation establishment said didn't understand airplanes. The economic impact rivaled the military impact. Willow Run's $200 million construction investment returned roughly $6.7 billion in delivered aircraft value. The factory's payroll pumped $450 million into Michigan's economy, transforming Ypsilanti from a college town into an industrial hub. Supplier contracts spread across 1,500 different companies in 31 states. An aluminum smelter in Tennessee produced wing skins. A rubber plant in Ohio made tires. A glass factory in Pennsylvania manufactured cockpit windows. Sorenson's assembly line connected American manufacturing capacity into a single coordinated weapon. By war's end, the B-24 program cost American taxpayers approximately $2.5 billion total across all manufacturers. Willow Run's share was $1.1 billion, 44%, an extraordinary concentration of investment in a single facility, and it paid off. The factory that Washington nearly cancelled in 1942 became the factory that proved industrial capacity defeats military genius every single time. But wars end. And when they do, the factories that won them face an uncertain future. Japan surrendered on August 15, 1945. Within weeks, Willow Run stopped producing bombers. Workers received termination notices. The mile-long conveyor stopped moving for the first time in 3 years. That massive building, the largest room under one roof, sat silent. Ford tried selling surplus B-24 seconds as cargo aircraft. Airlines weren't interested in gas-guzzling 4-engine bruisers designed for war, not profit. Willow Run eventually transitioned to automotive production. Kaiser Frazer bought the facility and produced cars there until 1953. General Motors acquired it next, using it for various automotive purposes, including transmission production. By 2013, most of the original structure had been demolished. A small section survives as a museum, preserved by the Yankee Air Museum after years of fundraising. The physical building is mostly gone, but Sorenson's method didn't die with the structure. It metastasized across every defense industry on Earth. The lesson was too obvious to ignore. Precision manufacturing and mass production aren't opposites, they're partners. You can build complexity at scale if you're willing to abandon craft tradition and think like an engineer instead of an artisan. The aircraft industry absorbed this first. Boeing's production of B-29 Superfortresses during the war copied Willow Run's subassembly system almost exactly. Post-war jet fighters, F-86 Sabres, and MiG-15 seconds came off assembly lines using Sorenson's conveyor logic. By the 1960s, every military aircraft manufacturer on the planet operated some version of his synchronized feeder line architecture. The ripple effects extended beyond aviation. Henry Kaiser, another automotive-adjacent industrialist, applied assembly line thinking to Liberty ships during World War II. He produced ocean-going cargo vessels in an average of 42 days instead of the traditional 6 months. Kaiser explicitly credited Willow Run as his inspiration. Post-war suburban housing developments used prefabrication and synchronized construction schedules lifted straight from Sorenson's playbook. William Levitt's Levittown homes were essentially B-24 seconds made of wood and drywall. Even modern semiconductor manufacturing, with its obsessive process control and synchronized workflows, descends intellectually from that 1940 hotel sketch. The philosophical shift matters more than the mechanical one. Before Willow Run, military procurement assumed weapons were bespoke items requiring artisan skill and extended timelines. Generals ordered equipment years in advance and hoped it arrived before the war ended. Sorenson proved that timeline is a choice, not a law of physics. If you engineer the production system as carefully as you engineer the product, you collapse delivery time from years to months. That insight permanently changed how nations prepare for conflict. Modern military doctrine assumes rapid industrial mobilization because Sorenson demonstrated it's possible. There's a darker edge to this legacy. The same principles that built 8,865 bombers also enable modern mass production of missiles, drones, and precision-guided munitions. Sorenson didn't invent war, but he invented a way to wage it at industrial scale with terrifying efficiency. The B-24 seconds that destroyed Ploesti's oil refineries also firebombed German cities. The system doesn't care about morality, it cares about output. That moral neutrality is part of why his method spreads so completely. It works, regardless of what you're building or why. Charles Sorenson himself retired from Ford in 1944 after a power struggle. He died in 1968, largely forgotten outside automotive history circles. No statues, no national holidays, no schools named after him. But walk into any modern automobile factory, any aircraft assembly plant, any facility that produces complex products at high volume, and you're walking through his cathedral. The religion is efficiency. The doctrine is synchronized flow. The prophet sketched it on hotel stationery in December 1940. Willow Run's final lesson is this: wars are not won by better generals or braver soldiers, though those help. Wars are won by better logistics, by superior production capacity, by the ability to replace losses faster than the enemy can inflict them. Germany produced 40,000 aircraft in 1944, an impressive figure representing maximum effort from a mobilized industrial base. America produced 96,000 that same year. Willow Run alone built one every hour at peak production. That's not a battle. That's mathematics. And Charles Sorenson, the car guy everyone said didn't understand airplanes, understood the only number that mattered. How fast can you build them before the shooting stops? His answer, drafted in pencil over one sleepless night in a California hotel room, was 55 minutes. The aviation expert said impossible. The military brass said delusional. History said correct. The arithmetic of industrial warfare reveals truths that generals rarely acknowledge and politicians prefer to ignore. When Adolf Hitler launched Operation Barbarossa in June 1941, his military planners calculated victory based on traditional metrics: troop strength, tank divisions, artillery pieces, Luftwaffe squadrons. They assumed industrial capacity was fixed, that America's manufacturing base, while impressive, had finite limits, that if Germany moved fast enough, struck hard enough, the war would end before American production could tip the balance. They were catastrophically wrong, not because German intelligence failed to count American factories. They knew about Detroit's automotive plants. They knew about Pittsburgh's steel mills. What they fundamentally misunderstood was the nature of American industrial capacity itself. It wasn't a fixed resource to be calculated and countered. It was an adaptive system capable of exponential transformation when properly organized. Willow Run represented that transformation in its purest form. The factory didn't exist in 1940. By 1944, it was producing more heavy bombers annually than the entire Japanese aviation industry. This wasn't incremental improvement. This was systematic revolution, and the revolution wasn't unique to aircraft. It was happening simultaneously across every sector of American manufacturing. Consider the broader industrial mobilization that Willow Run symbolized. In 1939, American industry produced approximately 6,000 aircraft total, military and civilian combined. By 1944, that number exceeded 96,000, military aircraft alone. The increase wasn't linear, it was exponential, and it happened because people like Sorenson proved that conventional limits weren't physical constraints. They were organizational failures. The same pattern repeated in shipbuilding. Traditional methods produced cargo vessels in 6 to 8 months. Henry Kaiser's assembly line approach reduced that to 42 days on average. His fastest Liberty ship, the Robert E. Peary, launched after 4 days, 15 hours, and 29 minutes. The mathematics were identical to Willow Run. Break complex products into manageable components. Manufacture components in parallel. Assemble with systematic precision. Replace craft expertise with systematic training. Tank production followed the same trajectory. In 1940, America produced approximately 300 tanks. By 1943, monthly production exceeded 2,000. The Ford River Rouge plant, which had manufactured automobiles for decades, transitioned to M4 Sherman tank production using assembly line techniques perfected on Model Ts. The same workers who had installed car engines learned to install tank engines. The same principles applied: standardization, repetition, flow. This wasn't unique American genius. It was systematic application of industrial principles that Sorenson and others had developed over decades of automotive manufacturing. The innovation was recognizing those principles could apply to weapons production, that a bomber wasn't fundamentally different from a car. Both were collections of standardized parts that could be assembled systematically if you engineered the process correctly. German industry never made this conceptual leap. They maintained craft-based production methods throughout the war. Each Panther tank was partially hand-built. Each Messerschmitt fighter required skilled labor at every stage. Quality was often superior to American equivalents, but quantity remained limited. Germany produced approximately 40,000 aircraft in 1944, their peak year. They lost the war that same year because 40,000 couldn't compete with 96,000. The mathematics were simple, brutal, decisive. Japanese industrial capacity faced even steeper limitations. Their entire 1944 aircraft production roughly equaled Willow Run's output alone. They couldn't replace losses, couldn't maintain numerical parity, couldn't sustain the attrition warfare that American industrial capacity enabled. Admiral Chester Nimitz reflected on this in his post-war memoir. "We fought across 5,000 miles of Pacific Ocean, supplied by ships built faster than the enemy could sink them." Japan's military planners assumed American industrial capacity was impressive but finite. They believed that if they sank enough ships, eventually American logistics would collapse, and we would be forced to negotiate. They failed to account for Henry Kaiser. By 1944, we were replacing shipping losses faster than they could inflict them. The mathematics of attrition favored the side that could build 3 ships daily over the side that could sink 2 ships daily. Industrial capacity, not martial valor, determined the outcome. The Pacific War was won in the shipyards of Richmond, Portland, and Baltimore, as much as on the beaches of Iwo Jima and Okinawa. This raises uncomfortable questions about the nature of modern warfare. If industrial capacity determines outcomes, then wars become exercises in manufacturing efficiency rather than military strategy. The side with superior logistics wins regardless of tactical brilliance or individual courage. This was true in World War II. It remains true today. Modern conflicts are won by supply chains, production capacity, and systematic organization. The romance of warfare, the emphasis on heroic individuals and brilliant commanders, obscures the mundane reality. Wars are accounting problems. Willow Run made this reality visible in ways that made both military planners and the public uncomfortable. The factory wasn't heroic, it was mechanical. Workers weren't warriors. They were employees clocking in for 9-hour shifts, installing the same components repeatedly. There was no glory in it. No dramatic last stands. No stirring speeches. Just systematic, relentless production. One bomber every 55 minutes, day after day, week after week, until victory became mathematically inevitable. The human cost of this system deserves acknowledgement. 42,000 people at peak employment working in conditions that were often dangerous, always exhausting, and occasionally deadly. Industrial accidents happened. Workers fell from assembly scaffolding. Machinery malfunctioned. Toxic fumes from welding and painting caused long-term health problems that wouldn't manifest for decades. The women who built these bombers, the African-American workers who broke color barriers, the teenagers who lied about their age to contribute to the war effort, they paid a price. Rose Will Monroe, the real Rosie the Riveter, worked at Willow Run installing rivets on fuselage sections. She was a widow with 2 young daughters. She needed the job. The 85 cents per hour, equal to what men earned, allowed her to support her family. But the work was physically brutal. Standing for 9 hours, repetitive motions that caused permanent joint damage, noise levels that destroyed hearing, chemical exposure that caused respiratory problems. She did it anyway. Thousands like her did it anyway, not because they were superhuman, because necessity demanded it and the system organized their efforts efficiently. This aspect of Willow Run's legacy often gets sanitized in popular memory. We celebrate the production numbers, we admire the engineering achievement. We rarely discuss the cumulative physical toll on workers who made it possible. They weren't volunteers on a patriotic adventure. They were employees doing difficult, dangerous work for wages that seemed good at the time but barely compensated for the long-term health consequences. The racial dynamics at Willow Run reflected broader American contradictions during the war. The plant employed African-American workers in significant numbers, breaking barriers that had existed in Detroit's automotive industry for decades. They earned equal wages for equal work, a radical concept in 1944, but they faced discrimination in housing, were often restricted to certain jobs within the plant, and returned home to a society that valued their wartime production but not their fundamental humanity. The same nation that celebrated Willow Run's diverse workforce maintained segregated military units. Black workers built the bombers. Black soldiers weren't allowed to pilot them in most cases. The irony wasn't lost on anyone. The war against fascism abroad was fought by a nation practicing apartheid at home. Willow Run's integrated assembly lines represented progress, but progress constrained by limitations that revealed how far America still needed to travel. These contradictions don't diminish the achievement, they complicate it. Willow Run proved that ordinary people from all backgrounds could accomplish extraordinary results when properly organized and given opportunity. That lesson had radical implications that extended far beyond aircraft manufacturing. If a widow with no technical training could learn precision riveting in 2 weeks, what did that say about claims that certain work required years of apprenticeship? If women could build bombers as effectively as men, what did that say about gender-based employment restrictions? The post-war period saw some of these lessons absorbed, others conveniently forgotten. The women who proved their capabilities at Willow Run were largely pushed out of manufacturing when veterans returned home. The racial barriers that cracked during wartime solidified again in peacetime, but the knowledge remained. The proof existed. You couldn't completely erase the evidence that the old systems of exclusion were based on prejudice, not capability. Sorenson's systematic approach to production influenced post-war manufacturing in ways that extended beyond weapons. The Toyota production system, developed in the 1950s and 60s, borrowed heavily from principles pioneered at Willow Run: just-in-time delivery, continuous flow manufacturing, quality control at every station, elimination of waste. These concepts that revolutionized global manufacturing all trace intellectual ancestry to that hotel room sketch in December 1940. Modern supply chain management, the complex global networks that deliver products to consumers with stunning efficiency, evolved from wartime logistics systems developed for factories like Willow Run. The ability to coordinate 1,500 suppliers across 31 states, ensuring components arrived at precise moments to feed an assembly line that never stopped. That organizational capability became the foundation for modern global commerce. Welding techniques refined under wartime pressure became standard in structural steel construction. Precision machining methods developed for aircraft components transferred to aerospace, automotive, and industrial manufacturing. The organizational principles of parallel production and simplified specifications became foundational concepts in operations management and industrial engineering education. But perhaps the most significant legacy was psychological. Before Willow Run, conventional wisdom held that certain tasks required master craftsmen. That complexity demanded expertise developed over years. That rapid training sacrificed quality. Sorenson proved all of these assumptions wrong. He demonstrated that systematic organization could replace individual expertise, that proper process design enabled ordinary workers to produce extraordinary results. That training time and production quality weren't inversely related if you engineered the system correctly. This psychological transformation rippled through American industry for decades. Managers who had accepted conventional limits on production suddenly questioned whether those limits were real. Engineers who had designed around assumed constraints started reimagining what was possible. Workers who had been told certain skills required years to master learned those skills in weeks. The shift wasn't immediate. Organizational inertia is powerful. But the proof existed. Willow Run stood as physical evidence that breakthrough performance required questioning fundamental assumptions. The factory closed, the bombers were scrapped. Most of the workers are dead now. But the revolution they created endures in every modern manufacturing facility that uses systematic production methods. In every training program that teaches specific skills rapidly, rather than broad expertise slowly. In every manager who questions whether impossible truly means impossible, or simply means nobody has figured out how yet. That is Charles Sorenson's enduring legacy. Not the 8,865 bombers he built, impressive as that number remains, but the transformed understanding of what dedicated people can accomplish when freed from the constraints of tradition and challenged to attempt what experts claim cannot be done. From December 1940, when he sketched an impossible factory, to June 1945, when the last bomber rolled off the line, Sorenson proved that industrial revolutions happen not through incremental improvements, but through fundamental reimagining of what is possible. The B-24 Liberators, built at Willow Run, carried more than bombs across oceans. They carried proof that human ingenuity, when unshackled from tradition and empowered by necessity, can accomplish the seemingly impossible. That wars are won by logistics and production capacity. That conventional wisdom can be wrong. That ordinary people, given training and opportunity, can achieve extraordinary results. These lessons, forged in a mile-long factory in Michigan during humanity's darkest hour, remain relevant wherever industries face challenges that experts claim impossible. The assembly line is silent now, but the revolution continues. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.